Hello and welcome to the next lesson of the numerical integration. In today's lesson, we will talk about Boole's rule. In the previous lessons, we had seen trapezoidal rule, Simpson's 1 by 3 rule, and Simpson's 3 by 8 rule. So like the previous rules or previous formulas, we will see Boole's rule. The way we derive Boole's rule is similar to the Simpson's 1 by 3, 3 by 8 or trapezoidal. If you have not seen the videos of these, so I request you first watch the videos of Simpson's 1 by 3 or Simpson's 3 by 8 or trapezoidal rule so that you will get to know how we can derive these formulas using Newton Cotes quadrature formula. So let's see Boole's rule, which is for you can see which is for n is equal to 4. So this is the Newton Cotes quadrature formula. We will be using this Newton Cotes quadrature formula to derive Boole's rule. Like in the other formulas, we can subdivide this larger integration into smaller integration. Here for n is equal to 4, the division would be in the interval which is having the difference of 4. So let's see how we can divide this x0 to xn in smaller intervals. So this will be x0 to x0 plus 4h, right? This is because n is equal to 4 here. So this will be fx dx plus the next smaller subinterval will be from x0 plus 4h to x0 plus 8h fx dx. And in the same way, we can subdivide more and more intervals and it will go till x0 plus n minus 4h x0 plus nh. So this will be fx dx. So in this way, we can divide the larger integration into the smaller subintegrations and we can perform the sum of these smaller subintegration to evaluate this larger integral. Now just to get this smaller integral, what we need to do is we need to substitute n is equal to 4 into the Newton Cotes quadrature formula. So we have already seen how this has been done in the previous formulas like Simpson's 1 by 3 and Simpson's 3 by 8. If you have not seen, I request you please go and watch first Simpson's 1 by 3 and 3 by 8, how we can put n is equal to 4 and we can get the formulas for this. So let me write the Boole's formula for x0 to x0 plus 4h. This is fx dx. This will be first subinterval. Let me remind you, this can easily be obtained by putting n is equal to 4 into the Newton Cotes quadrature formula. And remember, as it is for n is equal to 4, we will take only till the power of 4, order of 4, that is till del 4y. So we will consider the terms into the Newton Cotes quadrature formula till del 4y 0 and further terms will be ignored. So just by putting this n is equal to 4 into Newton Cotes quadrature formula and ignoring the terms which are higher than del 4y, we get the Boole's formula, which is equal to, this will be 4h within the brackets y0 plus 2 del y0 plus 5 upon 3 del 2 y0 plus 2 upon 3 del 3 y0 plus 7 upon 90 del 4 y0. So we have got this formula just by substituting n is equal to 4 here in the Newton's Cotes quadrature formula and taking the terms till del to the power 4y. Now we need to solve this and get this equation in the form of the y0 only. We need to put the value of this del y0. As we know, this is y1 minus y0. We need to substitute this del 2y0, del 3y0 and del 4y0s. We have already done in the previous formulas like Simpson's 1 by 3 and 3 by 8. So you can watch that Simpson's 1 by 3 or 3 by 8 videos to see how we can solve this. So now on solving this, we will get this is as 2h upon 45. Within the brackets, we will be having 7y0 plus 32y1 plus 12y2 plus 32y3 plus 7y4. So this is what we are getting after solving all these del y0, del 2y0 in terms of the y0, y1 and y2. So this is the first subinterval. Now we can write the second subinterval accordingly. X0 plus 4h. This will be x0 plus 8h fx dx. So now this will be 2h upon 45. We'll move this from y0 to y4 plus this is 32y5 plus this will be 12y6 plus this will be 32y7 plus 7y9. Right, in the same way, we can write more terms, and let me write the last term, which is x0 plus n minus 4h, and this will be x0 plus nh fx dx. This will be equal to 2h upon 45, and within the brackets this will be 7 yn minus 4 plus this will be 32 yn minus 3 plus this will be 12 yn minus 2 plus this will be 32 yn minus 1, and lastly this will be 7 yn. So these are all the subintervals that we can see. Now we need to sum these subintervals and this left side. Just by summing up these left side values, like we'll sum this, we'll sum this, and we'll sum this. So summing up, we'll get the larger interval x0 to xn fx dx. So let me write it here. On the left hand side, we'll get x0 to xn fx dx. And on the right hand side, we can take these terms common. As we can see, 2h by 45, 2h by 45, we are taking these terms common. So this will be 2h by 45. And now we can see this 7y0 is coming once in all these formulas, and this 7yn is coming once. So we'll keep them into one group. This will be 7 times y0 plus yn. And now we can see this is 32y1, 32y3, 32y5, 32y7 till 32yn minus 3 and 32yn minus 1. So we can keep them all in one group. This will be 32y1 plus y3 plus y5 plus y7 plus and so on till yn minus 3 plus yn minus 1. So this will be in one group. The next group could be, we can see that this is 12 by 2. This is 12 y6 till 12 yn minus 2. So the second group will be, this will be 12 within the brackets y2 plus y6 plus and so on till y of n minus 2. Now let me write the third group. Let's see which will be the third group. Here we can see this is 7y4 and 7y4 coming two times. Then we have 7y8 and 7y8 will repeat, and in the same way 7yn minus 4 and 7yn minus 4 will repeat twice. So we will take all these two times. So 7 plus 7, that is 14. So we will take here the third group in 14. So this will be 14 y4 plus y8 plus and so on till y of n minus 4. So this will be the third group. So now this is your actually Boole's formula that can be used to identify or to evaluate the numerical integration. Now we'll see this and we'll use this formula in the example. Now let's see this example. We need to evaluate this integral 0 to 4 dx upon 4x plus 5 by Boole's rule. So we need to solve this with the help of the Boole's rule. So first of all, we need to create the data table. So we'll be creating the data table, and we need to have the decision that what will be n here and what will be h here. So if you remember, this is Boole's rule. It has to be the number of intervals has to be the multiple of 4. So it is better that we keep 4 intervals here in this. So just to make 4 intervals, we will take n is equal to 4. So now once n is equal to 4, we can find out the value of h. That will be b minus a divided by 4, that is n. So this will be, as we can see, 4 minus 0 divided by 4. This will be 1. So here h comes to be 1, and we have taken n is equal to 4, which is a multiple of 4. We can take 4 intervals, we can take 8 intervals, we can take 12 intervals, because all has to be multiple of n is equal to 4 for the Boole's rule. So now let's create the data table for this. So in the data table, we'll have the values of these x and y, where y, as we know that y will be the function. This y is equal to 1 upon 4x plus 5, as we can see in the question. So this is 1 upon 4x plus 5. So y is 1 upon 4x plus 5. The value of x will begin with 0, then 1, then 2, then we'll have 3, and lastly we'll have 4. So 0 to 1, h is 1, 1 to 2, h is 1. So we have taken h is equal to 1. Now we just need to substitute these values into the function and get the value of y. So let's substitute 0 first. So this will be 1 upon 4 into 0 plus 5. This is 1 upon 5. So we can write here y as 1 upon 5. Next we'll substitute this x. In place of x, we'll substitute 1. So this will be 4 into 1. So now this will be 4 plus 5, that is 1 upon 9. So for x is equal to 1, this is 1 upon 9. Similarly, we'll use 1 upon 4 into 2 plus 5. This is 8 plus 5. So 1 upon 8 plus 5 is 13. Now for x is equal to 3, this is 1 upon 4 cross 3 plus 5. So this is 1 upon 17. And for 4, this will be 1 upon 4 cross 4 plus 5. This is 16 plus 5. So this is 1 upon 21. Now we can see that here this is x0, this will be x1, this will be x2, this will be x3, this will be x4. And respectively, this will be y0, this is y1, this is y2, y3, and this is y4. Now we'll simply use that Boole's rule. So we can see this is Boole's rule we have already defined, and we'll get the value of the integral. So we can write in the left hand side, this is 0 to 4 dx upon 4x plus 5. On the right hand side, we can see that this is 2h upon 45. Let me write the formula first. So this will be 2h upon 45. Then inside the bracket, we are beginning with y0 and yn. Here yn will be y4. So this will be 7 y0 plus y4. Then we'll have plus the next term. So the next term will be 32 of y1, y3, y5, and so on. So it will be 32. It will be 32 of y1 plus y3. That's it, because even we do not have this y5 here. So this will be 32 of y1 plus y3. The next is 12 times of y2, y6, and so on. So this will be plus 12 times of y2 only, because we do not have even y6 here in the table. So this will be 12 times of y2 in the third group. And the fourth group is 14 times. We are having y4, y8, and so on. And we can see that this is y4. So y4 we have already covered 1 times of y4 here. So this y4, so we will not take it twice. So now we'll remove this y4 1 times from here. So this y4 here will not be considered, and we'll keep this y4 here. So now this will be the formula, and we need to substitute the values. So we have h is equal to 1. So 2 into 1, 45. This will be 7 times y0. Here we have y0 as 1 upon 5 plus 32 times we have y1 plus y3. The value of y1 is 1 upon 9. The value of y3 from the table, we can see this is y3 is 1 upon 17 plus 12 times of y2. The value of y2 is 1 upon 13. So this is 1 upon 13 plus 14 times, we have 14 times y4, which is 1 upon 21. This is the final result coming with the help of the Boole's rule for n is equal to 5. I hope you have understood this Boole's rule and you have seen how we can get this solution, numerical integration using Boole's rule. You can also watch the other videos, Simpsons 1 by 3 and Simpsons 3 by 8 if you have not watched till now. So you will get a better idea of this Boole's rule. So that's it for the today's lesson. In the next lesson, we will meet with some more rule to evaluate the numerical integration. Thank you so much.